Hi everybody, today I will present the progress of my second project report in social network course and related to Kaggle Big Data Challenge. If you want to see my first project progress, you can click link in the description. Okay, let's jump to the main objective of this project. So our goal first is to predict a successful attempt based on several features. Of course, I have done the pre-processing stage where I carry a data mining process. There are also 3 new features that I add, and this feature helped me in boosting the performance of the algorithm in making prediction. The second objective is related to social network analysis. I will look for the relationship between players, or we can say the internal link between nodes, where node is the entities, for example kicker, returner, tackler, and the edge will be the relationship between them. Here, I will use college as connecting feature between each player, and in the end, the result will be useful for a best partnership recommendation between players. So, from Kaggle data, the most interesting statistic in the special team play tab, where we can see that kickoff and punt are the play tabs that contribute the biggest score in the special team. Therefore, an idea arose to see the relationship between kicker and returner. The point is the game. Kicker does not work alone in generating score. Support from other players will affect the outcome of the match. Likewise, the returner is not alone in trying to win the ball possession and also sell. After conducting an in-depth analysis of the Kaggle dataset, I see there are 3 types of players who have an influence of the kicker performance, such as gunner, tackler, and assist tackler, while on the defense team side, there are special team, safeties, punt rusher, and vice, which also have no less important role for the returner success in defending and even generating winning score. As for my recent progress is, I do prediction with 5 machine learning and 3 deep learning algorithms, and the results are very satisfying. The average accuracy is above 90%, and we can see that machine learning models have results that are not much different from deep learning models. As part for progress to my related social network, I use a directed graph to describe the relationship between kicker and returners to players who support their performance. For example, this is a graph that depicts the relationship between kicker and gunner with even score as the attribute. And in this example, we see a self-loop incident where the kicker also acts as a tackler in an event. Then, this is an example of player-kicker relationship based on the player university. Each colored node represents the player university. I also analyze the relationship between the returner and support system. And each graph, we do not see a self-loop, where in the defense position, in fact, each player will still move as the position in the formation. And in this graph represent between returner based on the player university. Then, what is the next step? The next stage is collaborating the directed graph into a heterogeneous graph so that we can do node prediction and of course look for pairwise recommendation to see if each player is compatible. And finally, we can find out whether the formation of the returner affect the performance of the returner and kicker. I think that's all of my presentation. Thank you very much.